Hello my friends, this video is going to be on how to solve systems of linear equations. We're going to use substitution. We're also going to use elimination. So this is going to be a rather lengthy video. So again, remember you can move around in it wherever you want to go. Otherwise, buckle up because it's going to be a bit. All right. First of all, we're going to talk about this system right here. Because this system has isolated y, we can solve for y. So because we know what y equals, and actually we know what y equals twice, we know y equals -7 minus 1, and we know y equals -9. Because we know that, we can take this value for y, and we can substitute it into the other equation where y would go. So we're going to take the first equation, and the first equation is y equals -7x minus 1. And we are going to erase the y, and we are going to replace y with its value. And the value of y is x minus 9. So we're going to put x minus 9 right here. And now we have gone from two equations to one equation with the variable x. And now we're going to solve. So this is why we started the school year on solving equations, because everything we do this year will require us to solve equations. So we are going to solve equations by adding 7x to both sides and adding 9 to both sides. If you don't want to do this in one step, you want to do it in two steps, you absolutely may. I'm going to do it in one step because these problems are long enough. 1x and 7x is 8x. -9 and +9 are 0. -7 and +7x are 0, and -1 plus 9 is +8. So 8x equals 8. Then I'm going to divide by 8. Divide both sides by 8 to isolate x, and x is equal to 1. Winner, winner, chicken dinner. Yay, we have a value for x. We have x is equal to 1. Now I know what x is. I can take the value of x and I can plug it into either of the first two equations. And I'm going to plug it into the second one. I'm going to substitute it into the second one because the second one will be easiest. So the second equation is y equals x minus 9. But I'm going to erase x, and I am going to replace x with what x equals. And x equals 1. So I'm going to replace x with the number 1. So I'm going to put the number 1 right here, and I have y equals -8. So I have a value for x and I have a value for y. What we have done is we have solved an ordered pair. Ordered pairs are always in the order of x, y. So we write our answer as an ordered pair. So we write our answer as 1. That's a terrible looking parenthesis. See if we can't do that better. 1 comma -8, because the value of x is 1, the value of y is -8. The ordered pair is 1 minus 8. In other words, if we would to graph the two lines, if we would have graphed the two lines like we did in our previous day of work, if we would have graphed the two lines, one of the lines would have done something like this. The other line would have done something like 1 minus 8 would have done something like this, and we would have found that they intersected right here at the ordered pair 1 minus 8. But we don't want to graph. We don't want to graph because graphing is ugly. People don't like to graph. So instead of graphing, we're going to solve the equation by doing substitution. Okay? So this question over here, set up for substitution. It's designed for substitution because I know the value of y. The value of y is -5x plus 30. So because I know the value of y is -5x plus 30, I'm going to take -5x plus 30 and I'm going to substitute in the other equation for y. So the other equation is 7x plus 3y equals 42. But I am going to remove the variable y, with my eraser, Whoops, I erased too much. And I'm going to replace y with this right here. I'm going to pick this up. Maybe. And put it right here. There it is. That's the value of y. I'll grab this and bring it back over here. So now I have the equation, 7x plus 3 times the quantity, negative 5x plus 30. Close the quantity equals 42. So now we're going to solve. We're going to take positive 3x, and we're going to distribute positive 3x. This is why we began the school year solving equations. So 7x, 3 times negative 5 is negative 15x. 3 times 30 is 90, equals 42. We are going to combine like terms. The like terms that we have that are alike, 7x and negative 15x, can be combined. So 7x minus 15x is negative 8x, plus 90 is equal to 42. Now we are going to move the 90, or we're going to isolate the negative 8x by adding the opposite of 90, by subtracting 90. So that's going to give us negative 8x is equal to negative 48. And then to isolate x, we're going to divide by negative 8. Both sides of the equation get divided by negative 8. That gives me x is equal to 6. And now that I know what x is equal to 6. X is equal to 6. Yay, yay, yay. Winner, winner, chicken dinner. If x is equal to 6, I can put it in where any x is. I can put it in there. Top equation, I can put it in there. I'm going to choose to put it in the first equation. I'm going to choose to put it in this equation right here. That equation is the equation. Y equals negative 5x plus 30. I could put it in the other equation, but this one, the math is easier. So x equals negative 6. So I'm going to remove the x. Gosh darn it, my eraser's too big. Hang on, let me get my eraser smaller. Should be able to give size. Yep, there we go. I'm going to erase this x, and I'm going to replace x with 6. So all I did there, friends, was I took this value of 6 and put it right there where x used to be. So now the problem is going to say y equals negative 30 plus 30. So now y is equal to 0. And again, it's an ordered pair. And the ordered pair is the x is 6 and the y is 0. So if we were to graph it, then we would have ended up with 6, 0 for my graph. So this is a shortcut. Substitution is a shortcut for graphing. Okay. So when we go to do this one, we notice this one isn't pretty. This one isn't pretty because nobody says y equals, yada, yada, yada. Nor does it say x equals, yada, yada, yada. So because we don't have a variable isolated, we have to isolate one of them. We can either choose to get this by itself, or we can choose to get this by itself. We could choose to get the x's by themselves too, but those would be harder than the y's right now. If I choose to get this y by itself, then the only thing I would have to do is to move the negative 3x over. So let's do that. Let's erase all this stuff that I've thrown on there. And let's take the very first equation and let's add 3x to both sides. And that's going to get us y is equal to 3x minus 5. All right. So now if you think about it, we have this equation and this equation. All right. So now I'm going to take the value of y, and I'm going to plug it in where that y is. So the first equation, the equation that used to say 2y is equal to 6x plus 10, I am simply going to take out my y, and I am going to replace y with what y is equal to. And that is what y is equal to, so I'm going to put it right there. Slide this back over so it looks all nice and pretty there. And then I'm going to solve this problem, because now I'm going to take and distribute the 2. I'm going to have 6x minus 10 is equal to 6x plus 10. And then if I go to solve, I would move 6x, and I would move the 10. And I would get 0 equals 20, which is not true. So because that's not true, these lines must be parallel. They do not have a solution. They do not intersect. All right. And I also frankly would have known that if I would have taken the first equation. So the first equation was 2y equals 6x plus 10. If I would have divided everybody by 2, I would have gotten y equals 3x plus 5, which is the same thing that I had right here. Oh, you know what? It's the same thing I had right there, so they're not parallel lines. Are they not parallel lines? No, that's not the same thing. Let me erase what I just said. They are not the same thing. You'll notice one of them, here, let me write it so you can see it underneath of it. One of them, matey, get it black, thank you. One of them was 3x minus 5, one of them was 3x plus 5. So here's the deal, my friends. Because they have the same slope, but they have different intercepts. You see negative 5 and positive 5 are different numbers, right? Because they have the same slope and different intercepts, they are parallel. They are parallel. They have equal slopes, different y-intercepts. So I could have done that without having to do the math either. So, at any rate, there's no solution, so we can't solve it. Let's move over here. Moving over here, let's see. Okay, so again, this is one of those we got to do a little bit of work because it doesn't say y equals anything. Y is not isolated. It also doesn't say x equals anything. X is not isolated. So we have to do a little bit of work before we can do anything. And the easiest variable to isolate is the one that doesn't have a coefficient other than 1. So the easiest one to isolate is this guy. So we're going to take that equation, which is x, which is x minus 7y equals 53. And we are simply going to move the 7y over. And x then would equal 7y plus 53. And this is why we did part 2 of unit 1, which was literal equations, was so we could isolate any given variable. Okay, now that we've done that, we have this equation right here and this equation right here. And we are going to take the value of x, which is 7y plus 53, and we are going to load it into the other equation. We are going to put it right here in this equation. We're going to substitute it in where it says x. So we're going to put it right there. So that equation That equation is negative 4x minus 5y equals 19. So we are going to take, let's make a little bit of space here. We are going to remove the x. We're going to take the x out, and we are going to replace the x with what x equals. And I haven't made a big deal out of the parentheses, friends, but you have got to use, you absolutely must use parentheses, or you'll lose the distributive property. All right, you'll lose part of your value of x. So you have to put parentheses around your value of x. Let's move this bad baby over here so it goes back together. There we go, all nice and pretty. All right, so now we have one equation with the variable y. So to solve, we have to distribute negative 4. So we're going to take negative 4 and we're going to distribute it over our value of x. So negative 4 times 7y is negative 28y. Negative 4 times 53 is negative 212. Minus 5y is equal to 19. And yes, this looks good. Now we're going to combine like terms. We do have like terms. We have like terms of negative 28y and negative 5y. So we're going to combine those. Negative 28 and negative 5 is negative 33y minus 212 equals 19. Now to solve, we're going to isolate negative 33y by adding 212 to both sides of the equation. We add 212 to both sides of the equation, giving us negative 33y is equal to, that's going to be a 9, 10, 11, 3, 2, 231. And then we're going to divide by negative 3y, divide by negative 33. I misspoke. We're going to divide by negative 33. And we're going to get y equals negative 7. Y equals negative 7. All right. Now that we know what y is, we're going to take the value of y. Follow me here. We're going to take the value of y. And we can put it in many places. We can put it right here where this y is. We can put it right here where this y is, or we can put it right here where this y is. I am going to pick this equation. Again, any equation will work, but this will be the easiest one math-wise. So I'm going to go x minus 7y equals 53. And I am going to remove the y, and I'm going to replace the y with negative 7. And that's going to give me x plus 49 equals 53. I am going to move the 49. I'm going to have x is equal to 4. So my solution is 4, negative 7. My solution is 4, negative 7. And voila, there is how we do that. So that's substitution. So now let's jump to elimination. Elimination, I use elimination when my equations are in standard form. In other words, when they do not say x equals and when they do not say y equals. Then all I'm going to do for this particular problem, I notice in this particular problem that my x's are opposites of each other. If those are opposites of each other, all I need to do is add the two equations together. Because when I add the two equations, the x's cancel each other out because x minus x is 0. And I have 7y plus 1y equals 8y. And 17 and 7 are 24. And then I can divide by 8. And so I would get y is equal to 3. And I don't know why I didn't do that in black ink. Y is equal to 3. Now that I know what y is, I can take the value of y and I can put it here or I can put it here. It doesn't matter where I put it. It's whichever one you like, whichever one you think will be easiest. I think for this particular problem, I'm going to put it in this equation right here. No specific reason why. Haha, no pun intended. So I have negative x plus y equals 7. I'm going to remove the y and replace it with its value of 3. So all I did there, friends, was I take and put it right there. And then we have to do the math, which means I have to subtract 3 from both sides. Subtracting 3 from both sides, I get negative x is equal to 4. So I divide by negative 1, or I multiply by negative 1, or I change everybody's sign, whatever your brain does for you there. That's totally up to you. But x is going to equal negative 4. So my ordered pair is negative 4, 3. Alrighty. So if we go over here, again, these are in standard form. And again, nice and pretty. I have a nice pretty setup because my y's are opposites of each other. So when that happens, all I'm going to do is go put an equals bar right here. And I'm going to add the two equations together. 3x's and 5x's make 8x's. The y's, positive 2y minus 2y is 0. And 22 and 42 are 64. And then I'm going to divide by 8. And so x is going to equal 8. Now that I know what x is, I'm going to take the value of x. And if I want, I can put the value of x right here. I can put the value of x right here. It doesn't matter. You'll get the same answer. If you do the math correctly, I think I'm going to pick this equation right here. Because I think the math will be smaller numbers for me. So that equation is 3x plus 2y is 22. I am going to remove the x, and I'm going to replace the x with its known value, which is 8. So in other words, I just tuck this 8 right there where x used to be. And then I do the math. 24 plus 2y is equal to 22. Isolate 2y by subtracting 24 from both sides. We subtract 24 from both sides to isolate the variable term. The variable term is 2y. It equals negative 2. Isolate the variable by dividing by 2. Divide by 2. And that gets us y equals negative 1. So y equals negative 1. Our answer is an ordered pair. 8, negative 1. Voila. Done. All right. Next. Oh my goodness, this isn't quite as pretty. This isn't quite as pretty because if you add these together, they don't cancel. They would give you 5x. Darn it. Okay. If we add these two, if we add these two together, they do not cancel. So we have to do a little bit of math first because we need them to be opposites of each other. We need x and y, x's or y's to be opposites of each other. We need, what do we need? We need x's to be opposites. Or we need y's to be opposites of each other. All right? Now, there's a couple different ways to do that. Probably the easiest way would be to take this entire equation, make that bigger. We're going to take this entire equation and we're going to multiply it by negative 4. Watch what happens when we do that. If we do that, then we are going to take negative 4, and we're going to take negative 4, and we're going to distribute it. Wow, that's really, really poor, Mrs. Leonard. We're going to take negative 4, and we're going to distribute it across the entire equation. That's going to give us negative 4x minus 20y equals negative 16. And you're thinking, why would you ever do that? Here's why you would do that. Because then you can take this equation, and if you put it right here, now you will see that these variables of x are opposites of each other. All right, so let's add those two equations together. Those two equations added together are going to be negative 29y is equal to negative 58. Then we would divide by negative 29. And that's going to get us y equals 2. Now that we know what y is, in theory, we can put y anywhere we want. We can put the value of 2 for y. We can put 2 here for that y, this y, this y, or this y. You can really put them in any of them. I always pick the one that looks like it's probably going to be easiest, looks like my numbers are smallest, look like there's less math to do, less negative signs, just easier altogether. And I think out of all 4 of those equations, this equation right here looks easier than all the other guys. So I'm going to say x plus 5y is equal to 4. I am going to remove y, and I am going to replace y with its value, which is 2. So I'm taking the value of y and putting it right here. And now I'm going to solve that equation. That equation says x plus 10 is equal to 4. I am going to subtract 10 from both sides of the problem. And that's going to get me x equals negative 6. So then my ordered pair is negative 6, 2. Okay. All right, here we go. So again, when we go to look at this, it's in standard form, so we want to eliminate, but we notice that if we were to look at these two, they do not cancel each other. Gosh darn it, that will not work. If we look at these two, they will not cancel each other. Gosh darn it, that will not work. So then we have to decide, well, what do we want to do? Well, we could do a lot of things, but probably the most straightforward thing is to take this equation right here and multiply it by the number negative 2. So let's look at that just a bit, okay? So before we jump in there, let's do this. Let me have this whole thing. I just want this part. Well, we'll take the whole thing. So here's the deal. We'll do it one more time also. There, okay. If I decide that I want to get rid of the x's, I need to come up with a 14x and a negative 14x because I need to get no x's, okay? And the first number that 7 and 2 go into is 14. So to do that, I would have to multiply this problem by 2 and this problem by negative 7. That's a whole lot of math. That is a whole lot of math. So if I look at the y's instead of the x's, whoops. Here are my y's, right? My y's would cancel out if I had a negative 6y and a positive 6y. Well, I already have a negative 6y here. So to get a positive 6y, I would just have to multiply this by negative 2, and that'll get me a positive 6y, which will get me no y's, which then will eliminate the y's, and I can do the problem. So that's why I am going to look at this problem, and I say I'm going to take this entire equation, and I'm going to take negative 2. I'm going to distribute negative 2. So I'm going to distribute negative 2. So what that means is I'm going to take this negative 2 in front of the parenthesis here, and I'm going to multiply it by the 2x, by the 3y, and stretch it all the way over here to the negative 13. In other words, the entire equation is being doubled and negated, or doubled and turned opposite, or doubled and have all of its signs change. In other words, I'm multiplying by negative 2. So when I multiply by negative 2, I'm going to get negative 4x plus 6y equals 26. Why do I do that? So now when I go up here and grab this other equation, the one I haven't touched yet, the one I haven't done anything to, and I put him right here, then I notice that, look at that. The y's are eliminated from the problem. So if I combine the two equations now, this is a little fat. If I combine the equations now, I have negative 4x and 7x, which is 3x. The y's eliminated or canceled or added to no y's equal negative. That's going to be a 7. That's going to be a 2. That's going to be a negative. Negative 27. And then I'm going to divide by 3, and I'm going to get x equals negative 9. So I get x equals negative 9. Now we're going to take the value of negative 9, the value of x, which is negative 9, and we can put it in any of our x's. We can put it right here. We can put it right here. We could even put it right here. We could even put it right there. Which one are you going to choose? It doesn't matter. It doesn't matter. You'll get the exact same answer. I picked the one where the math looks easiest. And in my mind, this problem right here is where the math looks easiest. The math is going to be smaller because my numbers are smaller. The math is going to be smaller because my 2x is positive right now. So that's what I'm going to do. So I'm going to pick that equation. That equation is 2x minus 3y is negative 13. I am going to erase the x. I'm going to replace the x with the value of x, which is negative 9. I took the value of x, which is negative 9, and I put it right there. Then I'm going to do the math. I'm going to have negative 18 minus 3y is negative 13. I am going to add 18 to both sides of the problem, which is going to give me negative 3y equals 5. And then I'm going to distribute by negative 3. And I'm going to get y equals negative 5/3. And that can be an answer. It's just rare that it's not an integer because teachers painstakingly work to make them integers for these problems. So I'm not certain. So I'm going to plug it in and see. So because I'm not sure, oh, by the way, I should write my answer. I should write my answer as negative 9, comma, negative 5/3. If I am unsure, I'm going to take my equation. I'll do it in red. And my equation is 7 times x minus 6 times y is supposed to equal negative 53. Well, this is negative 63. This would be positive 10. And that would equal negative 53. So negative 53 equals negative 53. Whoops, what the heck? Negative 53. So yay, it worked in the first equation. Yay. Doesn't work in the second equation. 2 times x, which was negative 9, minus 3 times y, which was negative 5/3, is supposed to equal negative 13. So this is negative 18. This is plus 5 equals negative 13. Woohoo! Look at this, my friends. Yay again. It works. Yay! It works. So yes, and your answers do not come out to be integers all the time. Life is a fraction, my friends. We might hate it sometimes, but it's still a fraction. All right, so yay, those worked. Okay, so here, this is our problem. And we notice these do not cancel. We notice these do not cancel. So then you say, which would you rather cancel? Would you rather cancel the x's or would you rather cancel the y's? And truly, friends, that is a choice that is up to you. Here's what I'm going to do. I am going to eliminate the x's. I'm going to eliminate the x's because I think dealing with the numbers 2 and 5 is easier for me than dealing with the numbers 3 and 7. So here's what I'm going to do. Watch this. I'm going to multiply this equation by 2, and I'm going to multiply this equation by negative 5. And remember, when we do that, that is a distribution all the way across the equation. All right, all the way across. So 2 times 5x is 10x. 2 times 3y is 6y. 2 times negative 7 is negative 14. That's the first equation doubled. So if I doubled the first equation, that's what I'd get. The second equation times negative 5 is negative 10x. Negative 5 times 7y is negative 35y. Negative 5 times 3 is negative 15. That is the second equation multiplied by 5 and taken the opposite of. All right? The reason I did that is now, right here, those cancel. Winner, winner, chicken dinner, life is good. This is negative 29y equals negative 29. Now I'm going to divide by negative 29. And I'm going to get y is equal to 1. And now that I know what y is, now that I know that y is equal to 1, now that I know that y is equal to 1, I can put it here, I can put it here, I can put it here, or I can put it there. I would put it wherever it is easiest, whatever is going to look good to you, whatever you think you're going to like. All right? And that, I think, I want to put it, I think I'll put it right here because the numbers are smaller. There aren't any negatives. I probably will not make any mistakes with this problem. So, this problem is 2x plus 7y is equal to 3. I am going to replace the variable y with its value, which is 1. So again, I just took the value of y and put it where y used to be. And that's going to give me 2x's plus 7 is equal to 3. I am going to subtract 7 from both sides of the problem in order to isolate 2x. That's going to give me 2x's is equal to negative 4. I'm going to divide by 2. That is going to give me x is equal to negative 2. So my answer is negative 2, 1. So the two lines would intersect at the ordered pair, negative 2, 1. And there we go, voila. Alrighty. Come over here. You know, there's a lot of things you could do with this. Let's talk about it. First of all, notice the x's do not cancel. Notice the y's do not cancel. So a lot of people out there would just jump in. A lot of people would say, I'm going to multiply this by 4. I'm going to multiply this by negative 3. And that way, these will become positive and negative 12s, and they'll cancel. You certainly can do it that way. Absolutely. Please, if that's what you want to do, that's what you can do. Somebody might decide that they're going to multiply this by 4 and multiply this by negative 3. And that would give you negative 36y. And that would give you positive 36y. And that would give you y's canceling. You can certainly do that. Again, whatever flies your planes and sails your boats. Here's what I notice. I notice the first equation are all multiples of the number 3. So I'm going to go divided by 3, divided by 3, divided by 3. That's going to give me x minus 3y is equal to 3. And I notice the second equation, those are all multiples of 4. So I'm going to go divided by 4, divided by 4, divided by 4. And that's going to give me x minus 3y is equal to 9. So what if I would have divided by negative 4? That would have given me negative x plus 3y equaled negative 9. And now when you add them together, not only my friends, do the x's cancel out. But so do the y's cancel out, but the constants don't. So you end up with 0 equals negative 6, which is no solution. So the lines must be parallel lines. They don't intersect. So what if you would have done one of those other things? What if we would have taken this and multiplied it by negative 4 and taken this and multiplied it by 3? Negative 4 times 3x is negative 12x. Negative 4 times negative 9 is positive 36y. And negative 4 times 9 is negative 36. 3 times 4x is 12x. 3 times negative 12y is negative 36y. And 3 times 36 is 72, and another one is 108. You add them together, and you would have gotten 0 equals 72, which is not true. The lines are parallel. What if you would have solved them for y and put them in slope-intercept form? If you would have put them in slope-intercept form, the first equation, do that in pink, first equation would have been negative 9y is equal to negative 3x plus 9, divide by negative 9, y equals 1/3 x minus 1. And if you would have done that to the second equation, you would have had negative 12y equals negative 4x plus 36. Divided by negative 12, you would have gotten y equals 1/3 of x minus 3. And then if you look, you have the same slopes with different intercepts. Your lines are parallel. All right, my friends, is there another one of these? There is not. So, explain when and why you would choose one method over the other. I would never pick graphing. Never. I hate to graph. Perhaps your teacher will come up with a better thing. Substitution. I'm going to use substitution when a variable is isolated. So when it says y equals something or x equals something, I'm going to use elimination when the equations are in standard form. I'm going to use elimination when a variable is not isolated. I like elimination over everything else. I use elimination as much as possible. But if a variable is isolated, I will go ahead and use substitution. And trust me, my friends, if I never have to graph another graph in my lifetime, I would be happy not to. Somehow, I think in my job, I probably will have to graph something somewhere in the future. All right, friends, there's like 45 minutes of your life you're never going to get back. Okay, have a great day.